So back to systematic error. So this is the same error each time. So I'll give you an example. I need to open up my... Here we go. What's wrong? So, for example... what's wrong? Are your hands cold?
No, I hear you.
Yeah. So, imagine we have something here that is measuring the mass here. So, for example, it says here 1.50 kilograms. And then you put on a different one and it says, 1.75 or whatever. But maybe this is broken. Maybe when you have the machine empty, so here is empty, it says 0.001 kilograms. So you see here, this is an error. And this error is on all the measurements. Each measurement, will it be too big or too small?
Too big.
This one is too big. By how much? Yeah, by 0.001 kilograms. This is what you meant to mean by an apparatus error. So this is an example of a systematic error. Each time this error is being applied to all the measurements. So this is what I mean by a systematic error.
Machine error?
It's like a machine error, yeah. So, I mean, you don't have to write these words down if you know them already. I just want to make sure you know them. Now, random error. What's a random error?
The environment error.
Yeah, so give me an example.
The table of two
A random error would be, the table might be shaken and so the water is not balanced each time. With the Newton experiment, a random error might be, again, the table is not horizontal. No, that's systematic, sorry. Random error would be, a random error with the electricity experiment. You notice that the voltmeter is jumping up and down. Why is it jumping up and down? Yeah, but what is causing the change? I think small changes in the temperature would affect the readings of the voltmeter. So these are random errors. You can't control them. They make a change up and down. And the key thing here is it's not possible to correct a random error. You can correct a machine error, you cannot correct a random error. Okay, so that's random error. Trueness is the closeness between the average value and the true value. It's very similar to accuracy, except it's just an average. Okay, I don't think you need this much vocabulary. Right, so this word you do need, precision. Okay. Now, don't write this definition down. Just write down this word and I'll explain it. Precision. You got this word, precision? Now let me explain it. Okay. I'm sure Lorraine showed you this picture as well. So here is my target. If I hit here, there's a big error. Yes? So we say that this is not accurate. Okay? What about this one? Is it accurate? No, it's also not accurate. However, these values are closer together than these values. Do you know what I mean? Like they are closer together. So we can say that this is at least precise. Precise. That the values are close together. What about this? In green.
Not precise.
Not precise.
And not accurate.
No, it's not precise, but if you take the average is accurate. Okay, so precise means how close together. Accurate means how close to the true value. Yes. So I'll draw it for you. I think it would be better. So let me draw the four possibilities. So this is precise and accurate, precise and accurate, precise and not accurate, not precise but accurate, and then not precise, not accurate. True value, true value, true value, true value. So here is precise and accurate. Here is precise and not accurate. Not precise but accurate. Not precise and not accurate. These are the four possibilities you can have. Of course, this is the best one and this is the worst one. This is also okay actually, and this is not great, but the reason for this might be a machine error, a systematic error. So in fact you could actually fix it possibly. But this is the worst one. You see the four uses of the words precise and accurate. So this is good, this is good, this is bad, but maybe we can fix it, and this is very bad, maybe impossible to fix. Okay, continue. Yes? So that's precise. I don't think I want to talk about uncertainty because I did already. So remember, uncertainty, I said at the start, it's, where's it gone? Oh no, it's closed, that's right. So for example, if you have something like, you can say, you think G, could be somewhere from 9.8 plus or minus 0.2 meters per second squared. So this here is your estimate, and this here is your uncertainty, how uncertain you are. So we usually put a little symbol, G bar, to mean your estimate, and the uncertainty is delta G, and this one here is the true value.
What is GT?
GT?
G.
This?
No.
G bar. Delta G.
The true value.
Oh, true value. G is, like this is, forget about it. The word I wrote for you, accuracy, how accurate it is. Okay. So here's the plan. On Monday we have physics. So what we'll do is, if you can bring your laptop, no, do we want to? Do you want to use the laptop now or later? Because first you need to do this. Do you want to do this on the weekend, or do you want to do some of this in class? Thought you might say that. Do you want to bring your laptop on Monday, or do you want to wait until maybe next Monday plus 1 week? Because before you can type the report, you need to do this part first. So maybe you just want to do this part first before using Excel. Yeah? Let me think. Okay, so what we'll do is, you don't need to bring your laptop on Monday, just bring your lab book. We'll have one physics class on the new chapter, and then in the second class, we can have a tutorial. You can work on your lab report, and I can help you make sure you're doing it right. Also, I will print some more blank ones, so if you make a mistake, I can give you a clean one. Yeah. Do you think 1 week is enough time to do this?
No.
No? Well, how much time do you think to do this? This one, just this one.
1 month.
No, seriously. Seriously?
No.
What have you got going on next week?
AAP.
EAP what?
And then we're gonna get our chemistry lab report. Now we have to do AAP and now physics.
We're talking on Monday. Alright.